Download this code from codegive.com, link in the description below. Missing bucket name validation with S3 listobjectsv2 API, a comprehensive guide. This tutorial will delve into the critical security aspect of validating the bucket name parameter when using the AWS S3 listobjectsv2 API. We'll explore why this validation is crucial, potential vulnerabilities arising from its absence, best practices for implementation, and provide practical code examples in Python using the Boto3 library. Understanding the S3 listobjectsv2 API. The listobjectsv2 API in Amazon S3 is a powerful tool for programmatically listing the objects stored within a specific bucket. It offers advantages over its predecessor, listobjects, including consistent pagination. Provides a consistent way to iterate through large sets of objects. Delimiter / prefix combination. Offers more flexible filtering capabilities. Object versioning, optional, allows you to list object versions if versioning is enabled on the bucket. Continuation token. Allows you to continue a listing from a previous interrupted call, crucial for handling large buckets. The core functionality revolves around specifying the bucket name as a key parameter. The API then returns a list of objects, and prefixes, if applicable, within that bucket that match the provided prefix and other filtering criteria. The critical importance of bucket name validation. The bucket name parameter is the gateway to accessing data stored in an S3 bucket. Without proper validation, an attacker could potentially manipulate this parameter to gain unauthorized access to data stored in buckets they should not have access to. Consider these scenarios. 1. Information disclosure. An attacker could provide a crafted bucket name to list the contents of a sensitive bucket. Even without the ability to download the objects, simply knowing the object keys, file names, can reveal sensitive information about the organization, data structure, or purpose of the files. 2. Lateral movement. If the application utilizes IAM roles with broad S3 access, a vulnerability in bucket name handling could allow an attacker to move laterally within your AWS environment, accessing different buckets than those intended. 3. Denial of service. An attacker could repeatedly call the listobjectsv2 API with requests for non-existent or extremely large buckets, potentially overloading your application and /or AWS S3 resources, leading to a denial of service. 4. Unintended data listing. If an internal application lists S3 objects for administrative purposes, and an attacker can inject a malicious bucket name, they might trigger the listing of sensitive production data into less secure environments, example a developer's machine or logging system. 5. Data exfiltration. In combination with other vulnerabilities, while directly exfiltrating the data usually requires download permissions as well, access to a bucket listing can be a crucial stepping stone in a more complex attack. For instance, knowing the file names, combined with other application vulnerabilities or stolen credentials, might allow an attacker to download specific sensitive files. Vulnerabilities arising from missing validation. Let's illustrate the potential vulnerabilities with a simple example. Imagine a web application that allows authorized users to browse files in their designated S3 buckets. The application receives the bucket name from the user's request, example as a query parameter, form input, or within a JSON payload, and directly passes it to the listobjectsv2 API without any checks. In this flawed example, an attacker could simply enter a different bucket name they suspect exists, example your company secrets bucket, to try and list its contents. Even if they don't have direct access to that bucket through their AWS account, a misconfigured IAM role assigned to the EC2 instance or Lambda function running this code could inadvertently grant them temporary permissions to list objects in that bucket. Best practices for bucket name validation. To mitigate the risks associated with missing bucket name validation, implement these essential practices. 1. Whitelist validation *. This is the preferred and strongest approach. Maintain a list of authorized bucket names that your application is allowed to access. Compare the user-provided bucket name against this whitelist before passing it to the listobjectsv2 API. Benefits of whitelisting *. Strongest security *. Explicitly defines acceptable values, preventing any unexpected or malicious bucket names from being used. Defense in depth *. Even if other security layers are bypassed, the whitelist acts as a final barrier. Clear policy * provides a clear record of which buckets the application is authorized to access. 2. Regular expression, regex, validation, use with caution if a whitelist is impractical. Example: dynamically generated bucket names with a consistent naming convention. Use a regular expression to validate that the bucket name conforms to an expected pattern. Important considerations for regex validation *. Complexity * regex patterns can be complex and difficult to create correctly. Ensure your regex is robust and covers all legitimate bucket name formats. Evolution * as your bucket naming conventions evolve, you'll need to update the regex pattern accordingly. Bypass risks * attackers may attempt to craft bucket names that bypass the regex. Thorough testing is crucial. Less secure than whitelisting * regex validation offers weaker security than whitelisting because it relies on a pattern rather than a definitive list. 3. Input sanitization, secondary defense. While not a substitute for whitelist/regex validation, input sanitization can help prevent certain attacks. Remove or escape potentially malicious characters from the bucket name before passing it to the API. This is particularly important if you're constructing the bucket name from user-provided data combined with other static parts. Important considerations for input sanitization *. Not a primary defense *. Sanitization alone is insufficient. It should complement whitelist/regex validation. Context-specific *. The appropriate sanitization techniques depend on how the bucket name is being used in your application. Potential for breaking functionality *. Overly aggressive sanitization can remove valid characters, causing the API call to fail. 4. Proper IAM permissions *. Adhere to the principle of least privilege when configuring IAM roles or user policies for accessing S3. Grant only the minimum permissions required for the application to function correctly. For example, if your application only needs to list objects in specific buckets, grant S3 list bucket permission only for those buckets, and not S3 *. Even with bucket name validation, limiting IAM permissions is crucial to minimize the impact of a potential vulnerability. Benefits of least privilege *. Limits the scope of damage *. Even if an attacker bypasses bucket name validation, their access will be restricted to the permissions granted by the IAM role. Reduces the attack surface *. Minimizes the potential actions an attacker can take within your AWS environment. Enhances compliance * supports compliance with security best practices and regulatory requirements. 5. Logging and monitoring * Implement comprehensive logging and monitoring to detect and respond to suspicious activity. Log all calls to the listobjectsv2 API, including the bucket name parameter, the source IP address, and the user or role making the request. Set up alerts to notify you of unusual patterns, such as frequent calls to list objects in the same bucket from an unusual IP address. Attempts to list objects in buckets that the application is not authorized to access. A sudden increase in the number of listobjectsv2 API calls. CloudWatch logs and CloudTrail are valuable tools for implementing logging and monitoring in AWS. 6. Regular security audits and penetration testing. Conduct regular security audits and penetration testing to identify and address vulnerabilities in your application, including those related to bucket name validation. Complete code example, combining whitelisting and sanitization. This example combines the best practices of whitelisting and sanitization for maximum security. Explanation *. 1. Allowed _buckets * defines a whitelist of acceptable bucket names. 2. Sanitize _bucket _name * sanitizes the user provided input by removing or escaping potentially malicious characters. This helps prevent injection attacks. 3. List _s3 _objects _secure * first, sanitizes the input. Then, checks if the sanitized bucket name is present in the allowed _buckets whitelist. Only if both checks pass, it proceeds to call the listobjectsv2 API. Error handling is included within the try/except block. 4. IAM role * make sure the EC2 instance or Lambda function running this code has an IAM role that only allows S3 list bucket access to the buckets listed in allowed _buckets. Conclusion: protecting your S3 buckets from unauthorized access requires diligent attention to security best practices. Missing bucket name validation when using the listobjectsv2 API can introduce significant vulnerabilities. By implementing a combination of whitelisting, input sanitization, proper IAM permissions, comprehensive logging, and regular security audits, you can significantly reduce the risk of data breaches and ensure the security of your data stored in Amazon S3. Remember, defense in depth is key. Never rely on a single security measure.